Welcome to our second video of our thermodynamics unit. In this video, we're going to be talking about the three common different temperature scales that scientists will use. Alright, so temperature, we got to start by defining that, is the average kinetic energy of a sample. So as temperature increases, kinetic energy increases, which hopefully you remember means movement also increases. Now, the three most common ways to measure temperature are by using the Fahrenheit, Celsius, and Kelvin scales. And in case you were wondering, this guy's last name is Fahrenheit. He invented that scale. This is Mr. Celsius. He invented the Celsius scale. And this is Lord Kelvin, who invented the Kelvin scale. I'm sorry, I don't know much more about them, but they are actually named after the actual scientists. It's kind of cool if you want to look into their work, but I don't know much about them. Alright. So the scales are commonly compared using the following table, where absolute zero is the temperature at which there is no kinetic energy, which is the lowest theoretical point possible. A gentleman named Robert Boyle actually theorized the phrase absolute zero. It's not physically possible for us to reach. We've gotten very close, but it's just can't quite physically get there. So, let me show you the three kind of most common points that we use to differentiate between the three different scales. First off, the freezing point of water. By Fahrenheit, that's at 32 degrees. Celsius is at 0. Kelvin is at 273. It's a little random. Fahrenheit, water boils at 212. Celsius boils at 100. Kelvin at 373. Absolute zero at Fahrenheit is really, really cold. Celsius is negative 273. The only one that actually has the zero part is Kelvin. Now, America, I believe the Cayman Islands and Belize, use Fahrenheit. The rest of the world uses Celsius. Celsius is actually based off of water. That's why at 0 it freezes and 100 it boils. Kelvin is made so that it actually has an absolute zero. You will never see a negative Kelvin temperature. It's not possible. So the main ones we will be using are Celsius and Kelvin, but we will be using Fahrenheit in some of our homework problems, mainly just so that you know how to convert between them. You will be using that likely for the rest of your life, or at least hearing of it, so I'm going to teach you how to use it. Now, let's get a little bit of comparison. So at the same temperature, at the bottom we've got absolute zero. They all freeze at this temperature. You'll notice that Celsius and Kelvin both only have 100 degree difference between water freezing and boiling. They're actually designed to be like that. Kelvin is just kind of a modification of Celsius. Fahrenheit, however, has a little bit bigger difference between boiling and freezing. The common equation you're about to see to convert between Celsius and Kelvin comes from this relationship. We're basically trying to match 32 degrees Fahrenheit to 0 degrees Celsius and try and factor in the fact that 1 Celsius degree is a bigger change than 1 Fahrenheit degree. Alright, so to convert between Celsius and Fahrenheit, this is the common formula people are taught. And you probably have heard that before, and you've probably forgotten it, because where does the 9/5 come from and stuff? I will tell you, it comes from that, on the previous slide, we had, thermometers. We had a difference of 180 on Fahrenheit and 100 on Celsius. If you take 180 and divide it by 100, you'll get 9/5. This 32 comes from the fact that we have a 32 and a 0. 32 minus 0 is 32. So where these numbers come from hopefully kind of makes sense, but they're still weird and random. So this is actually a way that we're going to be using in class. 5F equals 9C plus 160. Now, basically what that means is if you're solving for Celsius, plug in your Fahrenheit and solve for C. But here's why this is useful. Notice 5F. Another word that starts with F is finger. And on at least most of our hands, at least whatever this is, we have 5 fingers. That'll help you remember 5F. For 9C, another word that starts with C is cat. I'm going to try and draw a cat and it's going to look worse than the hand. Okay, I'm just going to keep talking. Kitty. Okay, but hopefully you've heard before that cats have 9 lives. It's just a random phrase because they always seem to land and live. So 5F, think of 5 fingers. 9C, think of 9 lives in a cat. And I have nothing to help you with 160. Good luck. But nonetheless, a little bit easier to work with. So let's move on. Now to convert between Celsius and Kelvin, much easier. You just add 273 to the Celsius temperature to get to Kelvin. So that's it. It's just 273. We are going to use the 0.15. It doesn't matter a lot, but if you take AP chemistry, you will be using that, so we're going to use it here. But much easier formula. All right, now it's time for an example. So first we are converting 96 degrees Celsius to Kelvin, and then we're going to convert to Fahrenheit, and we'll work on these other problems in a bit. So 96 degrees Celsius to Fahrenheit, we're going to use that equation. We have 5F is equal to 9C plus 160. I'm going to change this to black real quick. And now we can actually plug in our Celsius. So 5F is equal to 9 times 96 plus 160, which when you add that together, you get, 864 plus 160, which is equal to 1024. Okay, if we divide both sides by 5, since we're trying to get F by itself, we get that F is equal to 204.8 degrees Fahrenheit. Okay. Some of you may like the other formula with the 9/5. Go ahead. You're going to get the same answer. I've just found this equation is a lot easier to remember, and I prefer to teach you something that's you'll actually remember than you get the point. All right. Now, so we have 96 degrees Celsius. It's 204.8 degrees Fahrenheit. Lastly, we need to go to Kelvin. I probably should have done there first, but whatever. So Kelvin then is going to equal 96 plus 273.15. And again, yes, you do need the 0.15. It's 369.15. All right, and those are our two answers. 369.15 Kelvin and 204.8 degrees Fahrenheit. I'll wait for just a bit. Actually, no, I'm not. Why don't you pause the video now and try the rest? They're just plug-in formulas, and as always, I'll solve them for you. But pause the video, try the rest, and come back when you're done. All right. Hopefully wow, I can speak. Hopefully you're done. Let's move on. So in this next example, we are converting 350 degrees Fahrenheit to Celsius and Kelvin. Well, we don't really know how to go Fahrenheit to Kelvin, so let's go Fahrenheit to Celsius. That gets us 5 times 350 is equal to 9C plus 160. I think I'll keep the yellow. It's actually showing up a bit. Which gets you 1,750 is equal to 9C plus 160. That says that 1,590 is equal to 9C. And that says our C is equal to 176.7. So that says that 350 degrees Fahrenheit is equal to 176.7 degrees Celsius. And our Kelvin will then equal 176.7 plus 273.15, which is equal to 449.85 Kelvin. Those are your two answers. All right, if you haven't done the third one, pause the video right now, do it, but again, I'm assuming you already have, so I'm going to move on. And on our last one, we're going 298 Kelvin to Celsius and Fahrenheit. Again, we don't know Kelvin to Fahrenheit, so let's start with Kelvin to Celsius. Okay, so our Kelvin is equal to Celsius plus 273. Wow, this is not working too well. 15. Which means that we just subtract from our Kelvin to get Celsius. So that says that 298 is equal to Celsius plus 273.15. So Celsius is equal to about 24.85 degrees. More so, 298 Kelvin is equal to 24.85. Now that we have a Celsius, we can actually plug that in to get our Fahrenheit. So we have 5F is equal to 9 times 24.85 plus 160. Okay, when we multiply that out, we get that equals 223.65 plus 160. Which, when you add those together, gets you 383.65, which again equals 5F. Divide both sides by 5, and you get that F is equal to 76.7 degrees Fahrenheit. All right. Those are your two answers. Again, hopefully this makes sense. If not, rewatch the video. But yeah, that's how you convert temperature scales. Let me give you some practice. In this one, I'd like you to convert the following temperatures to the other scale. So Celsius to Kelvin, Kelvin to Celsius, you can read. And then once you've done all four, for two of them, also go to Fahrenheit. I told you most of your work is Kelvin and Celsius, but still good to remember how to do Fahrenheit. That's your practice. As always, thank you for watching.